The only way of discovering the limits of the possible is to venture a little way past them into the impossible.
The Interplanetary Podcast. The exploration of space for the benefit of all humankind. Your hosts here in England, Matthew Russell and Harriet Brettle.
Arthur C. Clarke.
Here we go, we're banging Arthur C. Clarke and a new guest host. Well, old guest host, old friend of the show, Harriet Brettle.
Oh, hi, man. It's great to be here.
Loads has happened with Harriet Brettle, hasn't it, since we last spoke?
I feel like throughout my space journey, the Interplanetary Podcast has been one of those guiding lights, you know? It's kind of, you know, like how in 2001 they have the those little sentinel blocks that appear in major stones. Oh,
yeah, right, okay.
Yeah, that's what the Interplanetary Podcast is for me. Every now and then you guys pop up and I love it. It's awesome. So
awesome, a bit like those weird metal things that were appearing recently everywhere.
They went a bit quiet, right? No one really found out what was going on there.
I always thought that was going to end up being really disappointing.
Like a Coca-Cola ad or something, right?
Yeah, I must admit, I don't know what happened to it. Maybe I'll find out for next week. Do some digging. Right, first of all, Harriet, I'm going to celebrate a birthday. I couldn't find any other astronomers or astronauts or anything born today, January the 18th. I know we're doing this on January the 17th, but it goes out January the 18th, 1971, which, if you didn't know, Harriet, is it's the optimum year to have been born.
You're saying that completely impartially and unbiased, I'm sure.
Very impartial. I just happened to be born in 1971. But yes, Amy Barger. Do you know Amy Barger, Harriet?
I had not come across Amy until thinking about this podcast, but she's awesome. What a cool job she has, right?
Yeah. Oh, no, absolutely. So, yes, she's the professor at Wisconsin-Madison University in the astronomy department. Big deal when it comes to things like observational cosmology. Something about the activity of black holes in nearby galaxies. That's what she's expert in.
Amazing.
Which, let's face it, is a pretty cool job, isn't it?
Can you imagine being at a dinner party and be like, what's your job? Oh, I study the activity of black holes in nearby galaxies. What do you do? Oh, what a way to live your life. It's amazing.
Yeah. I mean, when she was born, of course, they didn't really think that black holes existed.
Yeah, that must be amazing to study something where our understanding has expanded so much within your own lifetime, right? That's quite extraordinary.
That is nuts. So as we don't have a guest this week, I thought we'd do space news. It's a space news week, but it's been such a busy week. It's just a weekly space news because there's been a lot going on, even though it seems like there hasn't, because everyone's been sort of shut in their house. Actually, still stuff's going on.
Space doesn't stop.
Space doesn't stop, that's for certain. So the Parker Solar Probe, and I didn't realise it had been out this long, but it's done its seventh time it's done its dip straight, around the sun.
Oh, wow.
And it only seems to have only launched last year, but I'm sure it's been around for a couple of years now.
I think that's our weird understanding of time has just kind of, melted over this whole last period, right?
2020 has just disappeared. I have no idea what that was. It's gone.
Let's not talk about it anymore.
Let's not talk about it anymore. I don't know if you're aware, Harriet, but if you hear the name Elon Musk, you must shout the word drink. Because every time he's mentioned, we thought it would be a nice drinking game for people out there.
Oh, I love it.
That way, whenever you listen to the Interplanetary Podcast, you could probably get drunk because his name often comes up. So, but this one, Elon Musk, drink.
I've got a cup of tea. Does that count?
Oh, yeah, I think it does. I think you don't necessarily. Okay, get caffeined up.
Wild.
You don't have to necessarily. People in space often are pretty wild. There is actual drink associated with the Dragon this week. There was a Dragon capsule that landed for the first time in the Atlantic down near Florida, and it had a case of what, do you think?
I don't know. Well, I mean, some kind of drink, right? Are you going to tell me it was tea? Please tell me there's space tea.
I believe Tim Peake took tea up. He took Yorkshire. He took Yorkshire tea up, didn't he?
That is quintessential, isn't it? Of all the things for a British astronaut to take up.
If a Brit doesn't take some tea up to the International Space Station, there's something wrong. No. I mean, this is actually a French company. There's a clue. What will the French take up?
Cheese, wine, bread.
Wine.
Oh.
So it's a big case of Bordeaux was taken up. 12 bottles, all sealed up. Taken up because there's this a company called Space Cargo Unlimited. Although that doesn't sound very French, so I wonder if they have a French name. And they want to bring agriculture into the future and have a sort of organic and healthy future. And trying to work out how to do that. And one of the things is to see, and they think that the quality of life is determined by French food like cheese and wine.
I mean, I'm not going to say no to them.
No, absolutely. And yes, they sent up this wine, and they're going to open it up and see what it tastes like, and do a chemical analysis and see if space changed it.
So should we place our bets now? Do you think that the wine is going to get better or worse from being in space?
Or nothing?
Or no-
Do you think it might? Or nothing? Do you think there'll be no discernible? That'd be amazing. Imagine if it came back and it's the best bottle of wine anyone's ever tasted, and then suddenly there's everyone just keeps sticking crates of wine on things on the International Space Station.
There's been a few things like this that have happened recently, right? Because I think it was like Estee Lauder have put some like beauty face serum up into the space station, right, to do some promos. And you've got I heard of a company a while back that were planning to roast coffee beans on re-entry. I don't know if you heard about that.
Yeah, no, I did see that, but I don't know whether it happened. I don't know whether that one's happened. Yeah, but I did see that. That's quite a cool one because it's kind of it's actually using the heat that otherwise would have been wasted.
Right, there's a kind of purpose to it, right? Just send the wine up, bring the wine down.
Space roasted coffee beans.
Yeah, but no, that's exciting. I mean, this is kind of cool, right? Because it'll be interesting to see if there is a value add of putting these things in space beyond the fun factor, right?
Yeah, well, I think everyone's trying to think of commercial experiments you can do on the ISS. And let's face it, it's salvation if people are able to do more and more of these things.
Yeah.
Up in space. I believe that Dragon capsule brought back some of that Z-Blan fiber optic cable as well.
Oh, interesting.
They sort of make that fiber optic cable that can only be made in space, and it's like 100 times more efficient than the earthbound optical fiber.
Oh, great!
So
it was a big day for the capsule. They did a lot.
Yeah, well, I think there's mice in there as well. So it's one of those things that no one ever talks about the cargo of these things. But actually, if you read about the cargo, there's loads of things on board that are just like, what? They've got mice and bottles of wine and loads of vines as well. They had like loads of wine vines and stuff like that.
It's kind of like Mary Poppins's bag, isn't it? You go into the capsule. What are we going to find today? Here's a whole random collection of. Yeah, crazy.
Yeah, which I think is why they want things like the Space Rider. The Europeans are pushing things like the Space Rider because you can land your experiments in a sort of easy place rather than dropping it in the ocean.
Yeah.
And actually get your hands on an experiment really, really quickly, which might, of course, be vital for certain experiments. But no experiments flew up on the New Shepard this week. So Jeff Bezos, he flew. There was a New Shepard, a new booster, and a new crew capsule. So the RSS First Step.
Oh, did you see inside? It looks pretty snazzy, doesn't it?
It does look very snazzy. So that might be by the end of this year the first commercial space vehicle.
Yeah.
As in taking people up, doing that trip into space.
That's going to be huge, right? Because we've been talking. It's always been later this year for like the last 3 years. So
I don't know how many times I've had it at the beginning of the year where I've said, "Oh, we'll definitely see space tourism this year," and that's gone on for 3 years. But I don't know what the name of the logical fallacy is here, but there's a logical fallacy that says, "Oh, they always say it's going to happen this year, and it never does." Well, presumably that every time they say it, they must be closer to it being this year. That it can't be like they'll just say that indefinitely forever.
But that's how they get convinced. You. It's like, this time it will be different. This time they will launch. But yeah, I mean, having just acknowledged this fallacy, as you say, this year could be different, right? I feel like we're closer than we ever have been with both Blue Origin and Virgin Galactic, right? So
it's got to be close. It's got to be close because I think this one was good, although the booster didn't land anywhere near the middle of the target, which got Twitter in a big storm about how inaccurate it all was. But hey, it's obviously a different vehicle to the Falcon.
At least it landed.
It landed. It kind of does. It also does a kind of hover, so I think it's probably trickier to do that on the spot. But who knows? It was carrying 50,000 postcards from a sort of a little club called Club for the Future, which is a bunch of kids.
Oh, see, I know a little bit about Club for the Future, actually. So this, I'll tell you a little bit of inside info. Well, it's not inside, but some...
outside.
Outside info, yeah. So Club for the Future is awesome. So this is a kind of, I guess, non-profit spin-off that's come out of Blue Origin, right? And their objective is to get 1 million postcards flown in space. And so they have an awesome website. Anyone can, check it out. You can, it's for kids, but I think there's a lot of adults who would quite like to fly a postcard in space as well.
Oh, definitely.
But, you send them a postcard with a, return envelope. They'll fly into space, post it back to you. How cool is that? I love it. Such a cool idea.
Do you think people will start to make the distinction between my postcard has been in orbit or that has only been suborbital?
Oh, the space snobs.
Utter space snobs. Here's a question, though. Who's cooler, Mannequin Skywalker or Starman? Which billionaire's crash test dummy is cooler, Mannequin Skywalker or Starman?
So I'm going to say Mannequin Skywalker has definitely got the punnier name, so kudos on the name.
I agree.
But I think Starman has got
the Bowie reference.
Yeah, exactly. And don't they with SpaceX? They always stand up like a 0G detector, right? Which is like a plush toy or like
that little fluffy dinosaur thing.
Yeah, I think actually I'm going to put my vote on that little plush toy that goes up over both of them.
Yeah, the little dinosaur, which according to some people is the actual shape of the Earth, and it was for the astronauts to navigate with.
Oh yes.
Well, it's as believable as the Earth being flat. So now I think today we might see Virgin Orbit do Launcher 1.
Launcher 1, second time lucky, right?
Yeah, exactly. So that's got a bunch of really cool stuff on board, which we talked about last week. But it may or may not have happened by the time this goes out. And then this week is quite a busy week because so far only SpaceX has been into space in 2021, but it's going to be joined by maybe Launcher 1, maybe Virgin, maybe Electron. Another one leaves the crust, which I think is the second time they've used a Queen song, or maybe a third time they've used a Queen song as their reference.
I love it. There's something like just so much more fun about. It's just genius, isn't it? Because you could have your launch be like, oh, this is launch XBQYT, and you're like, oh, okay, fine. Give it a pun. It makes it so much more exciting, right? Yeah,
it's definitely more exciting than the ESA launches, which are like VA115 or something like that. It's like, I'm finding it hard to track which one I liked the most out of all of those.
Yeah.
But another one leaves the crust. You can't. I might have to add another one bites the dust to my to the space playlist now. Falcon 9, 60 more Starlinks. So a nice bunch of Starlinks up there again. iSpace Hyperbola 1, which is like a Chinese launcher, a private launcher. So they're kind of like the Chinese SpaceX, the iSpace.
Oh, wow.
And then another 10 Starlinks. Only 10 because they've got this satellite dispenser that's putting out a bunch of CubeSats as well on the same launch. So I think it might be one of the Falcon 9's first ride share things, one of these things, super low cost CubeSat launch.
Amazing.
So that's actually we should probably talk about that more next week when looking at it. Do you want to hear the most depressing story of all time? Possibly of all time. This actually might be the most depressing story of all time that makes COVID seem like a walk in the park.
Oh, you're really selling it there, I have to say.
I know. 2020 was the warmest year on record.
Oh, no.
According to NASA and its big fleet of satellites and hundreds of other resources that it's looking at this, there is a small margin of error that mean it might be tied with 2016 as the hottest year ever.
Doesn't really help though, does it? It's still pretty bad.
But it was the hottest year ever. So the average global temperature was 1 degree Celsius warmer than the baseline between 1951 and 1980.
Oh no, it's not great, is it?
1 degree is that. I mean, that is unbelievable.
Yeah.
I was when I was reading this report on the NASA website, I was kind of going, yeah, this isn't good. Yeah, there's the GISS director, Gavin Schmidt. He sort of said, it doesn't really matter about 1 year being hot. That can be an anomaly, but the kind of dramatic trend, the trend year in, year out is that it's getting hotter.
Mm-hmm. Well, that's the thing, isn't it? Because, you think, this was just a fluke year. But if every year for the last 7 years has been a fluke year, that's starting to tell you that it's probably not a fluke, right?
Yeah, well, you could, you could argue it was a fluke year because there was the global shutdown because of COVID and meant that there's reduced kind of smoke and particles in the atmosphere.
Oh, this was the thing. Yeah, because wasn't there, I remember there was kind of maybe it was when the first lockdown happened, there were these amazing images of, I think it was from like Sentinel satellite or something, looking at the pollution over Europe, right? And it had dramatically reduced. You'd have thought that 2020 might have been a good year for climate recovery, not the worst.
Well, I think we probably put slightly less carbon dioxide in the atmosphere, but not by much. I think when there's a recession, and those pictures from the Sentinels was of air pollution itself, wasn't it? All that, and so cities were much healthier as a result. But the actual kind of particles that go up into the atmosphere actually stop sunlight getting down. So without those, actually, you do get a warming effect. And when I was a kid, there was a concern about global cooling because of
little did they know.
Little did they know. Actually, the global cooling has actually been masking the global warming. But on the flip side of COVID's warming effect, there's been the Australian bushfires, which should have had the opposite effect. So there was like 40 million acres of land gone up in smoke. And obviously that smoke goes 18 miles up into the atmosphere and blocks the sun. So there's been the two confounding factors actually working against each other. So it's unlikely to be a fluke.
Oh, gosh, yeah, 2020. God, you forget, don't you? It started off with these horrific fires across Australia. And little did we know.
That's nothing.
We're just getting started.
I'm sure for the people of Australia it wasn't nothing, but
no.
There's been wildfires all around the world. I mean that it's since global warming started. I mean 1 degree Celsius has caused, loss of sea ice, sea level rise, heat waves, all the habitats that change all around the world, intense hurricanes. There's more hurricanes than there's ever been. So it's and that's after 1 degree. And the whole idea for 2050 to get that 2050 is to try and make it so it doesn't go to 2 degrees or over 2.5 degrees or something.
Oh gosh, we're almost halfway there.
Yeah, well, we might be over halfway there, because remember that the effect of the carbon dioxide doesn't kick in for ages. So we might have to start taking CO2 out to avoid that 2 degrees.
Yeah. Oh
Quite
gosh,
frustrating, isn't it?
it is.
But the good news is we do have a president now that actually wants to listen to scientists.
Well, in like 2 days' time. Don't hold your breath.
Oh no, that's true.
Don't tempt fate, gosh.
Trump might blow up the world in the meantime. So if you're listening to this, we have survived a psycho in the White House.
Oh gosh.
But yeah, so hopefully, yes, America will be back on board with things like the Paris Agreement. Who knows?
Yeah, and I think actually Biden, just over the last few days, has announced the members of his science team and seems to be actually taking them seriously, which is awesome. So he said, science will always be at the forefront of my administration, which is good news, right?
It is good
A
news.
nice change. And he's elevating the post of science advisor to the cabinet level, which is the first time that that position has had that level of seniority. So practicing what he preaches, I hope. We'll see how that plays out, right?
It is interesting. There is a kind of, I think what's missing at the moment is a kind of philosophy of science where scientists say stuff, but it's up to politicians to do stuff. Science doesn't tell you what to do. No. It only tells you what is probably true. That has been a slightly misunderstood, which has given scientists a bit of a bad name. Scientists don't tell us what to do. They just say, this is what we found, and then the politicians have to kind of look at it and go, this is what we should do about it.
Yeah, no, it's a really interesting distinction, actually, right? Yeah. Because
it's subtle.
Yeah, you say, oh, we've got to listen to the scientists. It's like, that's stage one, right? First you've got to listen to them, and then you've got to use that information to make your decision, right? So, yeah, it's a great starting point, but you still got to keep going.
It is a great starting point because Trump obviously was the classic, I'm going to listen to the scientists, and if it doesn't fit in with what I want to do, I'm just going to ignore it. I mean, he literally said it. I mean, it's not, I mean, that is on the record as something, because I hate getting political, but Trump literally said that, and obviously as someone who believes in science, it's hard to kind of stomach it. I don't think it's a political point at all. I think it's just not a good way of, particularly with this news, the 2020 being the warmest year on record, is like, it's just, you kind of got to pay attention, haven't you? Right, what was one of the most depressing things that happened in 2020?
Oh gosh, yeah, it was the fall of Arecibo, right? Those videos, the pictures, it's so sad, isn't it?
It was sad. I mean, it was pretty epic that they had all these drones and everything flying around while the thing collapsed. But there was something a little bit weird about it, wasn't it? It was like watching it's like rubbernecking on the motorway. Someone's had a car crash. It's like, yeah, that must be very depressing for, like, imagine if you're a research student or a research graduate and you've been working on a project for 5 or 6 years and it revolves around the Arecibo dish, of which there must have been hundreds and hundreds of people in that position. Yeah. And then it's like, it's not there anymore. It's like, and let alone all the staff that work there and the Puerto Rican economy and all those things, because that actually must be a sort of reasonably big part of it, I would have thought. Yeah, like a big research place. But yeah, no, there's actually been some reasonably good news on that front, because they're looking like that. Basically, the moment it collapsed, there was this guy called Ramon Lugo, who's the principal investigator, part of the University of Central Florida, I think, took over the place in 2018, which they must go, God, that was a bit not a great move. But he basically turned around to staff and said, right, staff, researchers, let's come up with a plan for something to replace the Arecibo dish, and it's got to be relevant for the next 50 years. It's got to satisfy planetary and atmospheric and astronomers. Everyone's got to be happy with it, and it's got to cost around $400 million. And I thought, Jesus, that's cheap. Does that sound cheap to you? $400 million to replace an iconic observatory.
I think when numbers get that big, it's very hard to like put them in context, right? Like 400 million. I was thinking, oh gosh, that's loads. But then, you think about the size of that dish. I don't know. Have they done it? Have they got a plan, Matt? Is there good news here?
Yeah, so they have. They put in this. Well, it's a mixed bag, this one, because they've put in this white paper that basically they have come up with a new design, and instead of being this enormous dish that, because the Arecibo dish is sat in a sinkhole, and instead of it being this enormous dish sat in a sinkhole, they're going to build a platform over the sinkhole and have 1,000 steerable dishes attached to that platform.
Oh, so it's lots of little dishes that can
lots of little dishes, yeah, rather than this big fixed dish. And one of the reasons why they want to do that is because its field of view will be 500 times bigger. So every time you observe, you can see 500 times more of the sky. But also, that is quite a good reason. But you can also see 2 times more of the sky in general as well. So which, and this is the cool bit, you can turn Arecibo now to have a look at Sagittarius A star.
That would be a cool thing to see.
I think one of the reasons why they want to do that in X-rays is so that you can look at something like a pulsar that might be in orbit around the supermassive black hole, and then using the super precise timing of the pulsar, which we'll talk about again in a minute, using that super precise clock-like timing, they'll be able to probe really, really deeply into the gravitational field of the central black hole, which of course will be further and further tests of general relativity and maybe new science.
Amazing.
So that looks really cool. And for me, $400 million, you would have thought, someone like Elon Musk could actually just go, yeah, just build it like that. I mean, generally, that's the sort of money he could just drop like that. If you think that Bezos, for example, is spending $1 billion a year on Blue Origin, 400 million, okay, it's almost half that, but it's like he could do it,
It could be done.
It could be done. So maybe private enterprise. And the reason why it might be private enterprise and not government is that the decadal review where they sit round and discuss what scientists want to do for the next 10 years has just been done. So of course you've got all these amazing projects that everyone wants to do that have or everyone's kind of all sat round and decided. So if you then brought this one in and said, this has got to jump the queue, you'd piss off all these other people that have spent presumably the last couple of years lobbying to get their big science project. And the other nightmare is Puerto Rico doesn't have a voting representative in Congress.
Right.
So it's harder for them to have someone bully the American institution into sort of getting these things over the line. But the Puerto Rican governor has allocated. Well, they probably do have alligators down there. $8 million to clean up the site and sort of do this review. So there's
hope.
There is hope. I genuinely, really, really hope that there's some hope there.
Yeah, and I quite like what you said about not just rebuilding it, but rebuilding it in a way where you can get more science, you've got more capability, you're building back better, but that sounds like a political slogan, doesn't it? Whose was that? Oh God.
Make Arecibo great again.
Yeah, I'm probably quoting some 2020 campaign. That's dangerous.
Yeah, MAGA, make Arecibo great again. That's fine. It's a sort of repurposing of some hats that will no longer be wearable.
Mm-hmm. Yeah, make Arecibo great again. I think that's the way you've got to,
We've just been talking about Arecibo, so we may as well go to my paper of the week. This is a great little science story, really super cool. And annoyingly, it is one of those papers that has revolved around the Arecibo dish. It's information from the Arecibo dish. So hopefully they're still able to carry on doing what they're doing. This is called the NanoGrav 12.5-year dataset. Search for an isotropic stochastic gravitational wave background.
So you know what we were talking about earlier with like catchy launch names? After we've gone through this, we need to come up with a catchy name for this paper.
Yeah, absolutely. Do you know what? When I read the abstract, I had no idea what it was talking about. It seemed really negative. It sort of it felt like they hadn't done anything. Luckily, there are lots of good news outlets out there that threw it and sort of broke it down for me. But I'd kind of got the gist in terms of nanograv is this North American nanoher observatory for gravitational waves, right? Mm-hmm. And instead of using LIGO or Virgo as the detector, mm-hmm. what you do is you have the entire galaxy as the big tunnel, and then you use pulsars as the lasers to Earth, right? And so as Earth sits in the sea, it's like bobbing about in the sea of gravitational waves, and you've got all these lighthouses that you can measure the distance to or the timings of.
Yeah. And
from that, you can kind of work out that you're bobbing around in the sea and what the energy is and what's causing it. And so wow. Obviously, this is really difficult because you're talking about because it's using the arrival times of these beacons as they come in, and obviously it's something ridiculous. It's like they only change by nanoseconds, few hundredths of a nanosecond, and the timescale difference only happens over years as well, so that it might only change by a few nanoseconds over 7 years or something.
So this is why this is a 12.5-year data set to make something out of this.
And it turns out that even that's not long enough. So that was the negative thing that I was reading through the abstract, was they haven't quite nailed it down. But this is looking really, really good in terms of they're pretty certain that there's a signal in there. And one of these things that they can do is look at the arrival times of pairs of pulsars. So if you've got one on one side and one on the other side, as you bob around, obviously, if there's any correlation between the two of them, you get this thing, the Hellings-Downs curve, which I thought was quite a cool thing.
Love it.
But if you can plot that and actually see more information, I guess it's a noise reduction technique essentially, but you can kind of start sort of saying, yes, that is significant and there's something going on. So this paper is the first time that they've actually used statistical analysis for years and years of data, and it looks like they're able to see the bobbing about of the Earth in the universe as supermassive black hole mergers are causing these giant low-frequency gravitational waves. So we're talking about a swell more than anything. So like neutron stars, when they smash into each other, are causing sort of big waves, whereas these supermassive black hole mergers are more like huge swells in the galactic ocean. And we're bobbing about in them, and this is potentially the first measurement of that.
That's amazing. That's really amazing. Something that kind of struck me about this is, like you said, this is 12.5 years, right? And one of the outputs was, that's maybe not long enough. This could be a kind of multi-generational survey, right? You imagine, you have 50-year data set. That could be something that you start as a grad student, and then, you hand over to your grad students, and, 3 generations of scientists down, you have these kind of findings, like... gives you a little bit of perspective of the grand scale of the universe, doesn't it?
Just the fact that we are bobbing about all the time, we're being sort of washed by these gravitational waves, and the fact that pulsars are just so useful. I mean, like, it's just incredible that there's these like little lighthouses, little clocks. Mm-hmm. More than a lighthouse, they're a clock as well. They're a clock and a lighthouse, like the GPS of the ocean, of the galactic ocean. And it's like they're becoming incredibly useful. So that's like the second time we've heard about them, the sort of these clocks out in the universe being used to kind of give us all this incredible information. Mm-hmm. But the fact, I think it's amazing that they're able to see these gravitational waves. I mean, particularly on the back of the fact that LIGO's only just seen them. Really, it's only been in the last 5 years, and now we're sort of heading into a period where we're able to see these things in lots of different ways.
Yeah, it's amazing. It's like, the first person like pushed open the door, and then you've got this flood of detections and, methods. it's extraordinary, isn't it?
If you were umming and ahhing about going into astronomy, I think it would definitely be a good time to go into astronomy. It's like the kind of like Uber time.
Yeah. Well, that's what's amazing, because I remember when I went to started grad school, and I was like, I kind of was like, oh, well, I'll study astronomy instead of, more the solar system stuff, because, surely we've got the solar system figured out by now. And then the more I learned about the things that were still to be discovered in planetary science, it kind of just blew my mind, right? There is so much that we still don't know, right? It's just
oh man, like you said, just in our own solar system, just in our own backyard. I mean, we don't even know how many planets there are. There might be a massive planet.
Still looking for Planet 9.
There might be a massive planet just out there, and then it may even be. I mean, I still love the story about that Planet 9 might be a little primordial black hole.
Well, yeah, I'm not sure about that one.
No, I mean, it's very, it's super tenuous, but crazier things have happened.
Well, I was going to say, yeah, that's the kind of thing that would have been discovered in 2020. So I think we're past that.
Well, the one that's the most surprising is when New Horizons flew past Pluto. No one suspected it was going to look anything like that. Right?
Yeah, just like, oh yeah, it'll be a cool rock.
It'll just be
maybe it'll look like the moon. Yeah, great.
It'll be like Mercury or something like that. Yeah, just totally.
And then what? Like the nitrogen ice plains. Like, oh gosh, yeah, that place is amazing, right?
And you think we didn't know anything about that Hubble is nowhere near powerful enough to see anything like that.
No. So obviously I'm biased, and I want to spend a little bit of time talking about Jupiter, if that's okay, Matt. But the one that's kind of blew my mind is, the Juno mission, and we should talk about Juno, because Juno's mission has just got extended for an extra few years. So hopefully we'll find out more. But it discovered these crazy polar cyclones, right, at the North Pole and the South Pole. And I'm going to get these the wrong way round, but I think the North Pole has got 5 cyclones in this pentagon, and the South Pole has got 8 in an octagon.
Yeah, those pictures are crazy, aren't they?
Yeah, and then the thing that blew my mind is after a few laps that Juno did, like an extra cyclone joined the party on the North Pole, and then there was 6 in a what is it, a hexagon, like. Yeah. What? Like, it just blows my mind that, firstly, we don't understand this incredibly weird phenomenon, and then it just gets weirder as we're watching it. It's just, it's amazing, right?
Yeah, it's the scale, isn't it, with Jupiter? Because Jupiter's so ridiculously big, as in you can't even begin to imagine how big it is.
Yeah, and
then and the scale of everything that's happening on it is crazy. I mean, that thing about Juno, the fact that it's when it's actually swinging so close to Jupiter, and it's actually getting relativistic effects from the gravity and the speed that it's going and everything else. It's like it's a crazy spacecraft, and the amount of radiation that it receives off Jupiter as well. The fact that it can survive that, it's nuts.
It's a crazy place.
I didn't really look too deeply in the Juno extension, but am I right in saying that it's actually going to be allocated some moons to look at as well? That it's going to sort of come out of its...
Yeah, so I think the thing is, because it's doing these flybys, right? So every 57 days, and it's because it wants to get really, really close to the surface of Jupiter, but you can't keep a spacecraft there. So it's in this very elliptical orbit, and for the first time it's going over the poles, which is why we've discovered these cyclones. I'm realising that I'm waving my hands and that no one's going to be able to see that on the podcast. No, you can imagine. So it goes really, really close, and then it gets really quite far away. And so I think, the idea of this extension is that they'll be able to time the furthest out point with skipping past some of the moons to get more of a closer look, right? So it says we'll also be able to expand its investigations of the larger Jovian system, including Jupiter's rings and large moons, with targeted flybys of Ganymede, Europa, and Io.
Wow!
Yes. Oh, just wait. It's going to be great.
It has to be said that there has to be some serious maths going on for the orbital mechanics for that, right? As in that the people in, I'm presuming it's JPL, will be
JPL.
sitting there working out these absolutely crazy orbital maneuvers to make that work. I mean, that is insane. Well, there's another space mission that's delivered. Fair play to NASA. They do seem to do this all the time, where they have these space missions that it's like, it'll work for a couple of years, and then it will be extended for 6 or 8 or something like that, and still deliver incredible science.
Well, you can't say no to a mission like Juno, can you? You'd be like, look, okay, it's done a very, very good job. Like, you can't be like, oh, sorry, guys. We've got a perfectly well working spacecraft, but, let's put it on hold for now. So, and InSight has got an extension as well, right? So that's going to be running until the end of 2022. So this is the Mars lander, right? Yeah. Which has had some bad news.
Yeah, that's
recently.
The Merle. The German Merle is dead. It's died. They've finally given up.
Oh, it's because it was stuck. Is that right? It was trying to drill and...
This just reminds me about going on holiday with my parents or scouts or something like that. When you go camping, when you hammer your tent pegs in, you never know whether you're going to get the tent peg in or not. Sometimes you bang it and it goes straight in and it's fine. And then other times you bang in it, you hit a stone and then you hurt your hand and the tent peg gets bent.
Yeah, and it's a lottery.
And it is a lottery even from plot to plot, let alone campsite to campsite. And I think that's
let alone planet to planet.
Let alone planet to planet. So I think that's kind of what's happened here. I think they've been a little bit unlucky that they thought they knew what the Martian regolith was going to be like, or the Martian soil and digging down, and it turns out no, it's not the right type of soil for this German mole to be digging down in. And they've tried all sorts of things. They've even tried whacking it with the arm of the InSight itself.
Oh, that was like some proper Martian, that was sci-fi, wasn't it? It's like, let's try and use the other arm to whack it in. It's like,
they scienced the F out of the German mole, but they didn't quite make it. Didn't quite nudge it down. It got down 50 centimetres and it was supposed to go down 5 metres. So bless it. But I would imagine that it's still lots of information about. So for the next time that they try doing something like this, they'll be able to do something, a little bit better. What's the thing,
right? You win some, you lose some. Like, the amount of discoveries that InSight has been able to do,
Yeah.
That's the challenge. You never know exactly what you're going to get. And they've measured like 500 earthquakes or something like that.
Or Mars quakes.
Mars quakes.
I've written earthquakes. I was like looking at it going, I'm not going to fall for my own.
But I did.
But 500 Mars quakes, yeah. And they weren't even sure there was such things as Mars quakes. Yeah. So that's again, yes, it's just science a go, isn't it? Yeah, InSight's been really, really cool as well. Yeah, absolutely. The last news story of this then is the God, we've managed to make this a very long episode. Is nuclear power in space. And this was quite a surprising one. I got an email from the UK Space Agency saying that they'd signed a deal with Rolls-Royce to look at nuclear space propulsion.
Yeah.
This is something I think that's going to make a massive resurgence, because I keep hearing about this from lots and lots and lots of different people. So I think that if we're serious about going to Mars or serious about like sort of bigger projects, I think we are going to have to start thinking about nuclear power again, because chemical propulsion just is nowhere near as good.
I think all of these deep space missions are using
RTGs.
Yeah, exactly. Yeah. Which is, I don't know. I don't think you can maybe call that a nuclear reactor, but it's
sort of isn't it? I mean, it's nuclear. I mean, essentially, it's nuclear power, isn't it? You're using the power of the atom to get you out to space. But yeah, I mean, the two NASA rovers are RTG driven as well, aren't they? The Perseverance and curiosity.
I think people just get a bit nervous when you use the word nuclear, right? It's got these images of disaster and destruction.
They do, but and there is a sort of problem of launching these things, isn't there? You know, the Perseverance rover launches on a very safe rocket. It's like, because if it crashes and spreads a bunch of plutonium everywhere, it is bad news. It's not great.
Yeah,
but I was quite surprised of how many nuclear reactors have been launched into space. Like, even back in the sort of late 60s, they were launching, test nuclear reactors up into space.
Yeah.
But yeah, this is the UK, and it seems like a really odd one on the surface, but actually, the UK turns out is actually got quite a good track record in this exact field. So obviously the BIS is one of the places that have talked about nuclear propulsion for a long time. So Alan Bond and Daedalus is nuclear propulsion, a little bit over the top because that's an interstellar craft rather than just going to Mars. But there's also the fact that there's a lot of universities, and in particular, obviously, the University of Manchester, where nuclear power was essentially invented. So, with Rutherford, of course, being a Kiwi Brit, I know that the Kiwis like to sort of have him as their own, hence the Rutherford engine on the Electron rocket.
Nice nod. Yep.
Yeah, it is a nod, but it's a little bit disappointing that the Rutherford engine isn't a nuclear engine, isn't it, really? It should be. If you're going to call a rocket engine a Rutherford, it should be a nuclear-powered engine.
Yeah, no, that's true. Yeah, maybe that'll be the next generation for them. Yeah.
But Rutherford should definitely go down as one of the biggest heroes of all time. Yeah, so we talked earlier, right at the beginning, about how, like, going through that entire generation of knowledge and how the world changes. 1917 was Rutherford's first man-made nuclear reaction. So it's only a little bit over 100 years ago, and you think how much
that's crazy
that we know beyond that now. Like, that's when he discovered the proton. It's like, what? It's only 100 years ago. Essentially it's only 100 years ago, and I think that's incredible. But yeah, so Rolls-Royce as well. And you think, well, what do Rolls-Royce know? Well, obviously Rolls-Royce know a lot about propulsion. Yeah. But they also build nuclear reactors, and they're actually looking at building 16 mini nuclear reactors called modular nuclear reactors, SMRs, small modular nuclear reactors, that are around the UK. So they're thinking of building these little sort of miniature power stations. And Rolls-Royce have always been involved in all these control systems and computer systems and stuff for nuclear reactors all around the world. So Rolls-Royce are experts. Loads of supply chains in the UK are specifically set up for a similar sort of thing. And obviously, we've got a big nuclear power industry as well. Mm-hmm. So it's not just a joke. There is actually some kind of cool element to this. In fact, super cool. The fact that the UK is actually looking at something as far out and as potentially, a transformative technology as nuclear propulsion in space. Halves the journey to Mars. And if you think about the ironic element of that, is that it halves the radiation dose that you would receive as an astronaut.
Oh, interesting. Yeah. And you know what? I've always thought about that, because Mars, what is it? What, like an 8 month to get there?
Yeah, 8 months.
That's a long time.
It's insane long time.
But 3 to 4 months, that
sounds more doable.
It does, doesn't it? That's a lockdown, that is,
Yeah, well, exactly. If you think about the difference between your food supplies that you require for 8 months and a 4 month journey is massively different, isn't it?
Yeah. Mm-hmm.
Like, there's so many elements to it, and how long your life support systems have to work for and what efficiency they work at. There's, that... Like, halving it is a big deal. Even knocking off 10% would be a big deal, but halving it would be like a proper big deal.
Mm-hmm.
Well, hopefully, I might be wrong. It might just be all wind, but it'd be good, wouldn't it, if that means that we're really serious about space. Of course, Harriet, you're in the epicenter of UK space, aren't you, at Harwell?
Yeah, it's it's really sad this year, because obviously everyone's working from home, so you don't get that kind of same community spirit, I guess, when everything's virtual, right? But I mean, honestly, Harwell is the place to be for UK space, right? I think there's over 100 space companies all in the same place, and that's really exciting because you're walking down the street and you've got, here's a company doing this, you've got a company doing that. Like, there's you were talking about it before in terms of, the UK supply chain and the whole ecosystem that's coming together, right? So, exciting things to come for sure.
Yeah, it is exciting. Harriet, thanks very much for being
it's a
being
pleasure,
my co-host.
As always. Yeah,
I need to get you on more often as co-host. It's good to have a new voice, new perspective.
Some good space chats for sure.
I'm going to say thanks very much to the patrons for their support as always. If you want to get in touch, then go to the website www.interplanetary.org.uk or go to our Patreon site patreon.com/interplanetary, and you can join the journey and join us on Discord, where Harriet's on Discord too now.
Woohoo!
Yes. And Chris and Julio, all the gang are there. It's going to be good. So I hope you all have a nice weekend. What are you going to do this week, Harriet, other in your lockdown?
Oh gosh, good question. I've got paint by numbers going on. That's just started that. It's my highlight of the week, I think.
Paint by numbers, is that your way to relax?
Yeah, it's very relaxing actually. And I haven't painted since I was literally a child, right? So it's it's quite soothing. I'd recommend it. And you end up with a piece of art at the end, which you can be very smug about. So win-win.
Yes, I painted this myself.
Exactly. No one needs to know there were numbers behind it, right? So
awesome.
How about you, Matt? What have you got to look forward to this week?
I'm finishing off. I've been working on doing a cover of Under Pressure for my Queen podcast that I have going.
Amazing.
So it's actually a good one. Under Pressure. What a song! Oh my god! I might have to do another one. Leaves the Crust now.
What, where you could actually swap the words?
Swap the words and send it to Peter Beck and go, Peter, I've done trying to do a New Zealand accent then and failed and accidentally did
something. Oh no, don't do that.
Don't do it. Right, that's it. Bye, Spud Cats.